For problem number 1, what we're going to do is we're first going to rewrite this as x cosine 36x squared dx. And I'm going to do u substitution. So before I try to do any other type of integration, I always try u substitution first. So that would make u 72x dx. So 1 over 72x du is equal to dx. So if I substitute everything back, I'm going to have x cosine of u times 1 over 72x du. Notice how my x are going to cancel. So 1 over 72 is a constant, so I just bring it down. The antiderivative of a cosine is sine. And then I just have to substitute u back. For number 2, it says which of the following series will converge? Well, series number 1 is a p series where p is equal to 2 and that is greater than 1. So 1 is going to converge. Okay, number 2 is what we call a harmonic series. It's also a p series. A p harmonic series where p is equal to 1, which is less than or equal to 1. So this is going to diverge. For 3, it's an alternating series. And notice that at the limit at n goes to infinity of 1 over the square root of n, that's going to be 0. So hence, by the alternating series test, this converges. So which ones converge? 1 and 3. Number 3, we want to find the coefficient of x sub 3 in the Taylor series. It's centered at 0, so we have the Maclaurin series. So first we're going to find f of 0. So that's just going to be 1. Then we're going to take the derivative. So at 0, that's going to be 3. We take the second derivative. So that's going to be 9e to the 3x. And when x is 0, it's going to be 9. And the third derivative is going to be 27e to the 3x. And when x is 0, it's 27. So my series is going to be 1 plus 3x plus 9x squared over 2 factorial plus 27x3 over 3 factorial. So we want the coefficient of x to the third. So 3 factorial is 3 times 2 times 1, which is 27 to the 6. And I can reduce 27 over 6 to 9/2. So the coefficient is going to be 9/2. For number 4, we want to find the third degree Taylor's polynomial. So third degree means that our x is going to be to the third. So we're going to find in the center around 2. So we're going to find f of 2. So that's going to be ln of 1, which is 0. So now we're going to take the derivative. So the derivative of ln is going to be 1 over 3 minus x times the derivative of the inside. And when x is 2, that's going to be negative 1 over 1 or negative 1. The second derivative, so let me rewrite this as to the negative 1. The second derivative would be 3 minus x to the negative 2 times the derivative of the inside. So when x is 2, I'm going to have negative 1 over 3 minus 2 squared, which is negative 1. Second derivative is going to be 2, 3 minus x times the derivative of the inside. And when x is 2, I'm going to have negative 1/2. So my polynomial is going to be 0 plus negative 1x plus negative 1 x minus 2. Oops, I forgot the x minus 2 here, because it's always at centered, minus 1 x minus 2 squared over 2 factorial minus 1/2 x minus 2 cubed over 3 factorial. So my answer is going to be negative x minus 2 minus x minus 2 squared minus x minus 2 cubed. So this is 3 times 2 times 1. For number 4, we need to find a third degree polynomial for f centered at x equals to 2. So we're going to start with f of 2. So that's ln of 1, which is 0. Then we're going to find the derivative, which is going to be 1 over 3 minus x times the derivative of the inside. So if we substitute 2, we'll get 1 over 3 minus 2 times negative 1, which is going to be negative 1. So to find the second derivative, I'm going to write this as negative 3 minus x to the negative 1. So the second derivative is going to be 3 minus 1 to the negative 2 times the derivative of the inside. So when I substitute 2, I'm going to have 1 over 3 minus 2 squared times negative 1, which is negative 1. So the third derivative is going to be 2 times 3 minus x to the negative 3 times the derivative of the inside. So when we substitute 2, we get 1 over 2, 3 minus 2 to the cube times negative 1, which is negative 1/2. Okay, so the third degree Taylor's polynomial is going to be f of 2 plus the first derivative of x minus where it's centered plus the second derivative of x minus 2 squared, 2 factorial plus negative 1/2 times x minus 2 cubed, 3 factorial. So I'm going to have negative x minus 2 minus x minus 2 squared over 4 minus x minus 2 cubed over, remember 3 factorial is 3 times 2 times 1. So it'll be 4 times 3, which is 12. For number 5, we're going to find the interval of convergence for the series. So in order to do that, we're going to go ahead and use the ratio test. So we're going to have the limit as n goes to infinity of n plus 1 x to the n plus 1 over 2 to the n plus 1 times the reciprocal so it's going to be the limit as n goes to infinity. So I just like to put all my like terms together. It's going to be n plus 1 over n times x to the 1 times 1 over 2. So since my limit does not depend on x, it only depends on n, I can factor out the x over 2 absolute value. So notice that this is going to go to 1 as n goes to infinity. So I get the absolute value of x over 2. So since we used the ratio test, we want this to be less than 1. So my radius of convergence is going to be between negative 2 and 2. So what I need to do is I need to check the endpoints to see whether the endpoints are included or not. So let me check when x is negative 2. So that means in my series, wherever I see an x, I'm going to substitute a negative 2. So I'm going to be able to write this as n times negative 1 to the n, 2 to the n over 2 to the n. So these cancel. And I have negative 1 times to the n. So this is going to infinity. It does not go to 0. It's an alternating series, but it does not go to 0. It actually goes to infinity. So this series diverges. So that means that negative 2 is not included in my solution. So now let's check when x is 2. So again, on my original series, wherever I see an x, I'm going to substitute it with 2. So notice these cancels. And this will also go to infinity. It doesn't converge, it diverges. So therefore, my interval of convergence is just going to be from negative 2, parentheses, comma 2. So it's not included. For part B, we need to show that the first 9 terms of the series are sufficient to approximate f of negative 1. So notice that it's going to converge at negative 1 because my interval of convergence was between negative 2 and 2. So I know that I'm going to converge. So what I'm going to do is I'm going to go ahead and substitute into my series. Wherever I see an x, I'm going to substitute negative 1. So what I want to do is I want to find the error less than the first 9 terms. So that means that I need to find the 10th term and show that the 10th term is less than 0.01. So my 10th term is going to be 10 to the negative 1, 10 over 2 to the 10th. So I get 10 over 2 to the 10th. And that is 0.00976, which is less than 0.01. So that means that the first 9 terms of the series is sufficient to approximate the series. So that means that to find this, I just have to sum the first 9 terms. And if I do that using the calculator, so the sum would be negative 0.2285. And there's going to be an error of 0.009. So my sum is going to be between negative 0.2285 plus 0.00976 and 0.00976 minus 0.2286. So the sum of the series is going to be between negative 2.383 and negative 2.187. For number 6, we're trying to find the values of x which the series is going to converge. So I'm going to use the ratio test. So I'm going to have x minus 1 times n over n plus 1. So once again, the limit does not depend on x, so that means that I can take out the x out. So the limit as n goes to infinity of n over n plus 1, so this goes to 1, so this is the absolute value of 1 x minus 1, and we want this to be less than 1. So my radius of convergence is going to be, right, so we're going to add 1 to both sides. So I'm going to get from 0 to 2. And now I have to check my endpoints to make sure that my endpoints are going to work. So let's start when x equals to 0. We're going to substitute that into my series. So I'm going to have negative 1 to the n over n. So this is an alternating series. And it's a decreasing alternating series. Remember, in order to use the alternating test, I have to show that this is a decreasing series, that the second term is always less than the first term. And it is. So, and the reason I know, because n plus 1 is less than, okay, so that's true. So all I have to do is show that the limit as n goes to infinity of the absolute value goes to 0, which it does. So therefore this converges by the alternating series test. So that means that 0 is part of my answer. So I'm going to have a less than or equal to there. So now we're going to show at x equals to 2. So when x is equal to 2, I get the series of 2 minus 1 to the n over n and this is going to be just 1 to the n over n, which is a harmonic series or a p series where p is equal to 1, and remember we need it if it's greater than or if it's less than or equal to 1, then my p series diverges. So that means that x equals 2 is not part of my solution. So my interval of convergence is going to be from 0 to 2. So I'm going to find the average value. So remember the average value is going to be 1 over b minus a from a to b of f of x. So that's going to be 1 over 2 minus 0 from 0 to 2 of x squared x cubed plus 1. So what I'm going to do is I'm going to go ahead and do u substitution. I'm going to let u be x cubed plus 1. So du is 2x squared dx. So if I substitute it back, my x squares are going to cancel. And I'm also going to do a change of variables. So I'm going to say when x is 2, my upper bound is going to be 9. And when x is 0, my upper bound is 1. And it just helps so that way I do not have to substitute u back. So 1/2 and 1/2 is just going to be 1/4. I just bring it down because it's a constant. So I'm going to add 1, so I get u to the 3/2 divided by 3/2 or multiplied by the reciprocal, and I'm going from 1 to 9. So I'm going to have 1/6 because I'm canceling, and I have 9 to the 3/2 minus 1 to the 3/2, which is 1/6 times the square root of 9 to the 3rd minus 1. And this is going to be 3, and 3 to the 3rd is 27. So I'm going to have 1/6 times 26. And if I reduce it by 2, I'm going to have 13 over 3. For number 8, I'm going to do u substitution. I'm going to let u be 14x plus 8x squared. So du would be 14 plus 16x. And I noticed that I can factor out a 2. So I'm going to have 1 over 2, 7 plus 8x. Du is equal to dx. So if I substitute everything back, notice that the 7 plus 8x are going to cancel. So I'm going to add 1. 1/2 is a constant, so it just comes down. So I'm going to have u to the 1/2 divided by 1/2 or multiplied by the reciprocal. So I'm going to have the square root of 14x plus 8x squared plus c.